Look up at the night sky for just a moment. You see those pinpricks of light, that vast, silent blanket of darkness. It feels peaceful, distant, almost separate from our busy lives down here. But what if I told you that this serene view is one of the universe's greatest illusions? What we perceive as a calm, almost static cosmos is in reality a seething, chaotic, and unbelievably violent arena where stars are born in colossal explosions. Black holes tear the fabric of space itself, and entire galaxies are locked in a silent, gravitational dance across millions of light years. We are living on a tiny, fragile rock in the midst of a drama of epic proportions that we are only just beginning to understand. Welcome, everyone. Today, we are embarking on a journey, a voyage beyond the simple twinkling lights to uncover the raw, untamed truths of the cosmos. We have gathered 50 of the most surprising, mind-bending space facts that will completely challenge your understanding of reality. Facts that reveal a universe far stranger and more wonderful than anything we could have dreamed up in science fiction. This isn't just a list of trivia, this is a gateway to a new perspective, a chance to pull back the curtain on the greatest show in existence. So get comfortable, open your mind, and prepare to have your concept of the universe turned completely inside out. Let's begin our countdown with a fact that starts close to home, a secret our own solar system has been keeping from us. Think about our closest celestial companion, the Moon. It feels like a permanent, unwavering fixture in our sky, a constant presence that has inspired humanity for all of our history, but that constancy is an illusion. Right now, as you read this, the Moon is in the process of leaving us. It's moving away from Earth at a rate of about 3.8 centimeters every single year. That's roughly the same rate at which your fingernails grow. While that might sound too slow to ever matter over the vast stretches of cosmic time, this slow drift has profound and irreversible consequences for our world. The mechanism behind this lunar escape is the gravitational tug of war between Earth and the Moon. This force is powerful enough to bulge our oceans, creating the tides. But there's a fascinating detail. Earth's rotation drags this tidal bulge slightly ahead of the Moon. That bulge then exerts its own gravitational pull, subtly tugging the Moon forward in its orbit, giving it a little extra energy that pushes it into a gradually wider path. It's a delicate and continuous transfer of energy, with Earth paying for the Moon's departure with its own rotational speed. This means our days are getting longer, imperceptibly lengthening by about 1.7 milliseconds every century. So, a distant future awaits where total solar eclipses, those breathtaking moments of daytime darkness, will become a relic of the past. The Moon will simply be too far away to perfectly cover the Sun's disk. Instead of the spectacular corona we see today, future observers would only witness annular eclipses where a ring of brilliant sunlight remains visible around the Moon's silhouette. This slow cosmic dance, measured in centimeters and milliseconds, is quietly reshaping the very fundamentals of our planet's relationship with space. But that slow drift of our Moon is a gentle waltz compared to the cosmic paradox waiting next on our list. If you think a year is a long time, consider the planet Venus. On this world, a single day lasts longer than an entire trip around the Sun. To be precise, Venus takes 243 Earth days to complete one rotation on its axis, but it streaks around the Sun in just 225 Earth days. This means that if you could stand on its scorching surface, the time from one sunrise to the next would be longer than the planet's entire year, and the strangeness doesn't end there. Venus doesn't just spin slowly, it spins backwards. From a vantage point high above the Sun's north pole, you'd see most planets, including our own, rotating counterclockwise. Venus, however, spins clockwise in what we call a retrograde rotation. This presents a monumental puzzle for astronomers. How did our sister planet, so similar to Earth in size and composition, end up with such a topsy-turvy spin? The leading theory points to a violent and turbulent early history. One compelling idea suggests that in the chaotic early solar system, a massive planetary-scale collision could have literally knocked Venus upside down, reversing its spin direction entirely. Another hypothesis proposes that the intense gravitational tugs from the Sun, and perhaps even from Earth, combined with the thick, soupy friction of Venus's incredibly dense atmosphere, acted over billions of years to gradually slow its original rotation to a standstill and then ever so slowly reverse it. This thick atmosphere, which creates a runaway greenhouse effect and surface temperatures hot enough to melt lead, acts like a colossal brake on the planet's spin. So, on Venus, the Sun rises in the west and sets in the east, and the calendar turns over before the day is even halfway done. It's a world where the fundamental rhythms of time we take for granted are completely and utterly inverted. Just when you thought the cosmos couldn't get any stranger, it serves up a cocktail on a truly astronomical scale. Drifting through our galaxy, 26,000 light-years from Earth near the center of the Milky Way, there exists an immense interstellar cloud known as Sagittarius B2. This colossal cosmic nursery, spanning an area larger than our entire solar system, has a composition that sounds like something from a science fiction novel. Within its frigid, swirling depths, astronomers have identified vast quantities of a simple organic molecule called vinyl alcohol. To be clear, this isn't the type of alcohol you'd find in a beverage. It's a key precursor to many of the essential building blocks of life. The sheer volume is almost incomprehensible. This single cloud contains enough vinyl alcohol to create a mind-boggling 1 octillion. That's a 1 followed by 27 zeros, liters of the stuff. This discovery is far more significant than a simple cosmic curiosity. It's a profound clue in our search for the origins of life in the universe. Molecules like vinyl alcohol are fundamental ingredients in the formation of more complex amino acids and lipids, the very components that make up cell membranes and proteins. Finding such a rich reservoir of this material in a single cloud tells us that the universe is not just capable of creating life's building blocks, but it does so on an industrial scale, scattering these organic seeds across star-forming regions in nearly every corner of the galaxy. The existence of Sagittarius B2 suggests that the chemical foundation for life is a common, almost inevitable, outcome of the complex chemistry that occurs within these vast stellar cradles. So, while you can't actually drink from this cosmic bar, its presence offers an intoxicating possibility. The universe may be brimming with the raw materials needed to spark life, just waiting for the right conditions to bring them together. While the idea of a cosmic cloud filled with organic material is astounding, it pales in comparison to the sheer, raw density of matter forged in the heart of a stellar cataclysm. Imagine taking the entire, sprawling mass of a city like Mount Everest and crushing it down until it could fit inside a single sugar cube. This isn't a thought experiment. This is the reality of a neutron star, the universe's ultimate pressure cooker. These stellar corpses are born from the dramatic death of massive stars in supernova explosions. When a star many times larger than our Sun runs out of fuel, its own immense gravity causes its core to collapse in a fraction of a second. The force of this collapse is so unimaginably powerful that it smashes protons and electrons together, fusing them into neutrons and creating a sphere of the most densely packed material known to exist. The numbers are genuinely difficult to process. A single teaspoon of neutron star material would weigh billions of tons here on Earth, a mass equivalent to every single human on the planet combined, compressed into a speck you could balance on your fingertip. This density creates conditions so extreme that the very rules of physics as we know them begin to warp. The surface of a neutron star is a perfect, seamless crystalline crust 100 billion times stronger than steel, and beneath it lies a quantum sea of neutrons behaving in ways we are still struggling to understand. Some theories even suggest that the very centers of these stars might contain a bizarre state of matter known as quark-gluon plasma, where the neutrons themselves break down into their fundamental components. The formation process is equally violent. The supernova explosion that creates a neutron star is for a brief moment brighter than an entire galaxy, blasting the star's outer layers into space and leaving behind this incredibly dense, rapidly spinning core. Many neutron stars become pulsars, emitting beams of radiation from their magnetic poles that sweep across space like a cosmic lighthouse. If that beam happens to point toward Earth, we detect a perfectly timed pulse of energy, a heartbeat from a stellar grave. These objects are not just cosmic curiosities. They are fundamental physics laboratories, allowing us to test the laws of nature under conditions we could never hope to replicate on our own world. They stand as stark reminders of the transformative and utterly destructive power that shapes the cosmos. Now, let's turn from the unimaginable density of a neutron star to a far more human, yet equally permanent mark on the cosmos. While Earth's winds and rains constantly reshape our world, erasing even the grandest of human structures over time, there is one place where our first tentative steps have been preserved with almost perfect clarity: the Moon. The footprints left by the Apollo astronauts are not just a symbol of human achievement. They are a literal time capsule, expected to remain perfectly intact for millions of years. This incredible longevity comes down to one simple, profound fact: the Moon is a world in stasis. It has no atmosphere, which means no wind to gently sweep the lunar dust, no water to erode the surface, and no weather of any kind to disturb the pristine regolith. The only forces acting upon those iconic impressions are the incredibly slow processes of micrometeorite bombardment and solar radiation. Think of it like this: on Earth, a footprint on a beach is gone with the next high tide. But on the Moon, the surface is a fine, powdery dust that, once compressed by a boot, becomes a solid, defined mold. Without air or water to break it down, that mold just sits there, exposed to the vacuum of space. The micrometeorites that do hit the surface are tiny, most no larger than a grain of sand, and they arrive sporadically over vast stretches of time. Their effect is more like a very, very slow sandblasting that will gradually, over eons, fade the sharp edges of the footprints rather than erase them all at once. This means the paths walked by Neil Armstrong and Buzz Aldrin, the tracks of the lunar rover, and even the discarded descent stages of the lunar modules are not just relics. They are the solar system's most enduring archaeological site. They are a snapshot of a single day, frozen in time, waiting for future explorers, whether human or robotic, to discover them exactly as they were left, a silent testament to the moment humanity first reached out and touched another world. Moving from the enduring silence of the Moon's surface to the void that surrounds it, we encounter one of the most counterintuitive truths about the cosmos. Space itself is utterly and completely silent. In the vacuum of space, where there is no air or any other medium for vibrations to travel through, sound waves simply cannot propagate. This means that the most cataclysmic events imaginable, a star exploding in a supernova, two black holes colliding with enough force to ripple spacetime itself, or the constant nuclear furnace of our sun, all occur in a profound and absolute hush. If you were floating in a spacesuit near a massive cosmic collision, you would experience the event as a purely visual and tactile phenomenon. You might see an incredible flash of light and feel the vibrations through your suit, but your ears would register nothing. This silence is why spacecraft communication relies entirely on radio waves, a form of light that can travel perfectly well through the emptiness. It's a stark reminder that our earthly experience, where sound is a constant companion, is a privilege granted by our atmosphere. The universe conducts its most spectacular symphonies in a vacuum, performing for an audience that can only watch and never hear. And the greatest performer in our local cosmic neighborhood, the Sun, holds a dominance that is almost difficult to comprehend. While we see it as a disk in our sky, that brilliant sphere contains a staggering 99.86% of all the mass in our entire solar system. This single fact redefines our perspective on our own place in the cosmos. Every planet, from the gas giant Jupiter to our own humble Earth, every moon orbiting those planets, every asteroid tumbling through the asteroid belt, and every icy comet in the distant Oort cloud, all of it combined represents a mere 0.14% of the solar system's total mass. To put it in more relatable terms, if we could place the entire solar system on a cosmic scale, the Sun would be a massive bowling ball, and everything else would amount to little more than a few scattered grains of dust. This overwhelming concentration of mass is the sole reason the solar system exists in its current form. The Sun's immense gravity is the anchor that holds everything in its intricate orbiting dance. It dictates the orbits of the planets, governs the paths of comets, and its gravitational influence extends far beyond Pluto, shaping the very structure of our celestial neighborhood. This also means that the diverse and complex worlds we study, with their mountains, oceans, and atmospheres, are truly just the leftover scraps from the Sun's formation, the tiny fraction of material that managed to clump together while the vast majority collapsed to form the central star. It's a humbling realization that we are living on an exquisite, beautiful, but cosmically insignificant speck, orbiting a true titan whose sheer presence defines the space around it for light years in every direction. Far from the silent, frozen footprints on our moon, the universe continues to forge wonders that defy even our wildest imagination. Consider a world where the very ground beneath your feet would be unimaginably precious. 40 light-years away, orbiting a star visible to the naked eye, lies the exoplanet 55 Cancri E, a world so rich in carbon that scientists believe a significant portion of its interior is composed of crystalline carbon, in other words, a planet with a core of diamond. This super-Earth, with a radius twice that of our own world and a mass 8 times greater, orbits so close to its parent star that a single year passes in just 18 hours, and its surface temperatures are hot enough to melt iron. It's a world of extremes where the very high pressure and temperature conditions have likely compressed the planet's abundant carbon into a diamond structure on a planetary scale, creating a glittering, burning jewel adrift in the cosmos. But this isn't a serene, beautiful gem as we picture it. It's a hellish landscape, potentially with a surface of graphite that literally rains diamonds in the scorching atmosphere. This discovery shatters our preconceived notions of what a planet can be, revealing a universe of staggering chemical diversity where the building blocks of life can, under the right conditions, become something utterly alien and magnificent. While 55 Cancri E represents one kind of planetary extreme, our own solar system holds a world undergoing a dramatic transformation right next door. Mercury, the smallest and innermost planet, is not the geologically dead relic we once thought. Recent evidence from spacecraft like NASA's a messenger probe has revealed that Mercury is, in fact, still cooling and shrinking. As its massive iron core slowly loses the heat left over from its formation over 4.5 billion years ago, the planet is contracting. This process causes the planet's single outer shell, its crust, to crumple and fracture. Think of it like a grape slowly shrinking into a raisin. As the interior contracts, the rigid skin has to wrinkle and fold to accommodate the new, smaller size. On Mercury, this has created immense cliff-like landforms called lobate scarps that can run for hundreds of miles and soar up to thousands of feet high. These are not ancient features, they are active geological wrinkles, and the presence of small, fresh-looking faults suggests this global contraction is ongoing even today. This makes Mercury a surprisingly dynamic world, its surface still being reshaped by the deep, internal cooling of its core, a process that connects this small, scorched world to the fundamental thermal evolution that governs all rocky planets. This ongoing geological activity on Mercury is matched by another, more visible peculiarity in its rhythm of day and night. Due to its unique orbital resonance, a single day on Mercury, the time it takes for the Sun to return to the same point in the sky, lasts for 59 Earth days. But the relationship between its rotation and its orbit creates a truly bizarre effect. The planet's year, one trip around the Sun, takes only 88 Earth days. This peculiar combination means that a single day on Mercury is actually 2/3 of its entire year. If you were standing on its surface, you would witness a sunrise that seems to crawl across the sky. The Sun would appear to rise, then slow down, stop, and even reverse its course for a short time before resuming its path and finally setting, all over the course of those 59 Earth days. This strange dance is a result of Mercury's eccentric, oval-shaped orbit combined with its slow spin. For a period near its closest approach to the Sun, the planet's orbital speed is so much faster than its rotational speed that the Sun's apparent motion in the sky is temporarily overtaken, creating this incredible backward loop. This means a single Mercurian day experiences extreme temperature swings, from 430 degrees Celsius at noon to -180 degrees Celsius at night, a 560 degrees Celsius temperature range that is the most severe in the entire solar system. So, from a diamond world light years away to our own shrinking, slow-spinning neighbor, we see that the inner solar system is a place of continuous change and incredible physical extremes. Now, let's turn our attention to the outer solar system, where the gas giants reign, and each one presents a spectacle of celestial dynamics that dwarfs anything found closer to the Sun. First, consider Jupiter, a planet so massive it could swallow every other world in our solar system with room to spare. Its most famous feature is the Great Red Spot, a colossal storm that has been raging for at least 4 centuries. This is not a typical storm, it's a hyper-tuned anticyclone, an enormous high-pressure system that churns in Jupiter's southern hemisphere. To truly grasp its scale, imagine a vortex wider than our entire planet Earth, with winds that scream at speeds exceeding 400 miles per hour. That single storm system, a swirling tempest of crimson clouds, is larger than the whole world we call home. What's even more astonishing is its longevity. While hurricanes on Earth dissipate after a few weeks over the ocean, the Great Red Spot has persisted for hundreds of years because it's an engine that runs on Jupiter's own internal heat, with no landmass below to disrupt its flow. Recent observations show it is slowly shrinking, and its once vivid color has faded to a more muted salmon hue, but it remains a breathtaking symbol of the raw, untamed power that defines the Jovian system. While Jupiter boasts a storm of epic proportions, its ringed neighbor Saturn presents us with a vision of ephemeral beauty on a cosmic timescale. Those iconic, brilliant rings that define Saturn's appearance are not permanent. In fact, they are in the process of a slow but steady disappearance, composed predominantly of water ice particles ranging in size from tiny dust grains to large boulders. The rings are being pulled by Saturn's gravity in a phenomenon that scientists call ring rain. This isn't a gentle drizzle. Data from the Cassini spacecraft revealed that an Olympic-sized swimming pool's worth of icy material is raining down from the rings and into Saturn's upper atmosphere every single day. This constant downpour is driven by a complex interplay of solar ultraviolet radiation and the planet's own magnetic field, which electrically charge the tiny ice particles and funnel them along magnetic field lines toward the polar regions. Given the current rate of loss, astronomers estimate that Saturn's magnificent rings have only another 100 million years left to exist. In the grand multi-billion-year history of our solar system, that's a relatively short chapter. This means that for most of Saturn's life, it likely did not have these prominent rings, and in the distant future, it will appear as a nearly featureless gas ball. We are living in a privileged moment, a cosmic golden age where we can look up and see Saturn in its full, ringed glory, a temporary crown that is gradually melting away. This graceful, fading spectacle around Saturn stands in stark contrast to the peculiar and extreme orientation of the next planet out, Uranus. This ice giant has a rotational axis tilted so dramatically that it essentially rolls around the Sun on its side. While most planets, including Earth, spin like tops with their rotational axes more or less perpendicular to their orbital plane, Uranus is tilted at a jaw-dropping 98 degrees. Imagine a bowling ball rolling down a lane with its finger holes pointing toward the ceiling and floor. That's Uranus in its orbit. This profound tilt creates the most extreme seasonal cycles in the entire solar system. For roughly a quarter of its 84 Earth-year orbit, one pole is pointed directly at the Sun, experiencing 42 years of continuous daylight, while the other pole is plunged into an equally long, frigid winter of total darkness. Then, as it continues its journey, the roles reverse. The leading theory for how Uranus ended up in this bizarre state points to a cataclysmic event in the early solar system, a series of colossal impacts with planetary-sized objects. One or more gargantuan collisions are thought to have literally knocked the planet over, reorienting its spin axis and leaving it with this unique rolling motion. This violent history may also explain the planet's unusually cold and quiet interior, as the impact could have ejected much of its primordial heat. So, as Jupiter hosts a centuries-old Earth-sized storm and Saturn slowly loses its iconic jewelry, Uranus performs a slow cosmic somersault, a perpetual reminder of the chaotic and violent processes that shaped our planetary family. We have already stretched our minds to grasp the immense scale of our own solar system, but to understand the next fact, we need to expand our perspective to encompass the entire cosmos. The total number of stars in the observable universe is so colossal that it surpasses one of the most abundant things we can conceive of on our own planet. Astronomers estimate there are roughly 1 septillion stars, which is a 1 followed by 24 zeros. To put that almost meaningless number into a tangible context, scientists have calculated that there are more stars in the visible universe than there are grains of sand on every beach and in every desert on Earth. Every single grain you have ever let slip through your fingers on a warm afternoon is outnumbered by a sun, many of which likely host their own families of planets. This realization transforms a simple walk along the shore into a truly cosmic experience, where the countless sands beneath your feet become a humble metaphor for the true, staggering vastness of creation. This unimaginable sea of suns provides the canvas for one of the most profound capabilities of modern astronomy, the ability to look back in time. The Hubble Space Telescope and now the James Webb Space Telescope function as time machines. This isn't science fiction, it's a direct consequence of the finite speed of light. Light travels incredibly fast, but across cosmic distances, even it takes time to arrive. When we look at our moon, we see it as it was just over a second ago. When we gaze at the sun, we are seeing it as it appeared about 8 minutes in the past. Hubble pushes this principle to its absolute limit. By staring at a tiny, seemingly empty patch of sky for days on end, it collects the faint, ancient light that has been traveling for billions of years. The most famous of these images, the Hubble Ultra Deep Field, reveals thousands of galaxies, each a smudge of light that represents a snapshot from a distant epoch. Some of the faintest objects in that image are galaxies whose light was emitted over 13 billion years ago, when the universe was in its chaotic infancy. We are not seeing these galaxies as they are today. We are witnessing their birth, seeing the first generations of stars igniting in the cosmic dark. Every time we peer into the deep field, we are opening a photo album of the universe's childhood, watching history play out in the silent, patient light from the dawn of time. And this grand cosmic history has a dramatic future chapter already written. While we observe galaxies billions of light years away, one of our closest galactic neighbors, the Andromeda Galaxy, is on a direct collision course with our own Milky Way. Right now, Andromeda is hurtling toward us at a speed of about 110 kilometers per second. Don't worry, you don't need to clear your calendar. This galactic merger is scheduled for about 4.5 billion years from now. What will this cosmic event look like? It will be less of a violent crash and more of a slow, graceful, gravitational dance. Because the vast spaces between stars are so immense, it is incredibly unlikely that any two stars will actually collide. Instead, the two galaxies will pass through each other, their gravitational forces dramatically warping and stretching their spiral arms into long, streaming tails of stars. They will then swing apart before falling back together, slowly merging over hundreds of millions of years to form a new, larger galaxy that astronomers have nicknamed Milkomda. From within this evolving system, any future observers would witness a night sky transformed beyond recognition, filled with a brilliant, chaotic tapestry of new stars and glowing gas clouds, a permanent testament to the dynamic and ever-changing nature of the universe on its very largest scales. We have already touched on the staggering density of a neutron star, but let's make that truly tangible. If you could somehow transport a single teaspoon of this material to Earth, it would weigh about 1 billion tons. To grasp that, picture an entire mountain range, something like the entire mass of Mount Everest, compressed into a tiny cube of sugar that could sit on your kitchen counter. That's the incomprehensible power of gravity in one of the universe's ultimate pressure cookers, where matter is squeezed into a state that defies all everyday experience. Shifting from the cosmic to the microscopic, we find another surprise unfolding much closer to home, aboard the International Space Station. In the unique microgravity environment of orbit, some bacteria behave in unexpected and frankly unsettling ways. Scientists have discovered that certain pathogens like Salmonella, the bacterium responsible for food poisoning, actually become more virulent in space. Experiments have shown that Salmonella cultured on the space station can be up to 3 times more likely to cause disease in animal models than the same bacteria grown on Earth. The reason appears to be a fascinating response to the physical stress of microgravity. The low fluid shear environment where things float freely instead of settling tricks the bacterial cells into behaving as if they are in a constant state of starvation, triggering a master genetic switch that makes them more robust and dangerous. This isn't just a laboratory curiosity, it's a critical area of research for long-duration spaceflight. As we plan for missions to Mars and beyond, understanding how to keep astronauts healthy and ensuring that common microbes don't turn into superbugs in their closed environment spacecraft becomes a matter of mission success and crew survival. The silent, invisible world of microbiology is just as affected by the space environment as the human body, reminding us that life adapts in surprising ways when we leave our planetary cradle. And speaking of leaving our cradle to look outward, our final fact in this trio takes us to the very edge of our own solar system, where a compelling mystery is waiting to be solved. For years, astronomers have noticed that a collection of small, icy bodies in the distant Kuiper belt beyond Neptune's orbit share a peculiar trait. Their orbits are clustered together in a way that strongly suggests they are being shepherded by the gravitational pull of something much larger. The math points to the existence of a hypothetical giant planet, often called Planet 9. This world is theorized to be about 5 to 10 times the mass of Earth, tracing a long, elliptical orbit that takes it hundreds of times farther from the Sun than we are. Finding it, however, is like searching for a single, dim light in the expanse of an entire continent. Its proposed orbit is so vast that a single trip around the Sun could take up to 20,000 years. The evidence is purely gravitational for now. We can see the effect this object seems to have on other bodies, a ghostly signature in the paths of distant ice dwarfs. Several ongoing surveys are meticulously scanning the predicted regions of the sky, hoping to catch a glimpse of this potential new world. Its discovery would be a monumental event, rewriting our solar system's map and giving us a new, massive neighbor whose very presence would tell a dramatic story of our solar system's early and possibly violent history. While we often look to the cosmos for extremes, the coldest place we have ever discovered or created is not out in the dark void between galaxies, but right here in a laboratory on Earth. Scientists using lasers and magnetic traps have succeeded in cooling certain atoms, like rubidium, to a temperature just a fraction of a degree above absolute zero, the theoretical point where all atomic motion stops. This state of matter, known as a Bose-Einstein condensate, can reach temperatures as low as 38 trillionths of a degree above absolute zero. That is significantly colder than the natural background temperature of deep space, which hovers at a comparatively warm -455 degrees Fahrenheit. In this bizarre condition, atoms lose their individual identities and begin to behave like a single superatom, a wave of matter that acts in ways that defy classical physics. This achievement isn't just about winning a cosmic chill contest. It allows us to probe the fundamental quantum nature of reality, opening doors to new technologies like ultra-precise quantum sensors and quantum computers. It's a profound reminder that some of the universe's most extreme frontiers are being explored not with giant telescopes, but on laboratory benches. This delicate, ultra-cold science happening on Earth is conducted in pristine, controlled environments, which stands in stark contrast to the increasingly chaotic and cluttered environment just a few hundred miles above our heads. The space around our planet is now home to a swirling cloud of human-made debris known as space junk. This isn't just a few lost screws, it's a growing collection of defunct satellites, spent rocket boosters, fragments from explosions and collisions, and even flecks of paint, all orbiting Earth at speeds exceeding 17,000 miles per hour. At such velocities, even a tiny chip of paint carries the kinetic energy of a bowling ball thrown at 60 miles per hour, posing a catastrophic threat to active satellites and the International Space Station. The problem is self-perpetuating. A single collision between two objects can create thousands of new pieces of debris, each capable of causing further collisions in a cascading chain reaction known as the Kessler syndrome. This scenario could potentially render entire orbital pathways unusable for generations, trapping us on our own planet. Tracking and mitigating this debris is now a critical field of space operations, with companies and agencies developing concepts for debris removal, from harpoons and nets to laser nudging. It's an invisible environmental crisis of our own making, a testament to how our celestial ambitions are leaving a permanent and hazardous mark in near-Earth space. Amidst this orbiting junkyard, the human body itself undergoes a remarkable and temporary transformation. Without the constant compressive force of Earth's gravity, the spinal column is free to expand. The discs between the vertebrae, which are composed of a gel-like material, slowly decompress and stretch out. This process can add up to 3% to an astronaut's height, meaning a 6-foot-tall astronaut could return to Earth nearly 2 inches taller. While this might sound like a free height boost, it's not without its complications. This spinal elongation is often accompanied by back pain, as the muscles and ligaments supporting the spine must adapt to a new configuration. Furthermore, the added height is only temporary. Once back in Earth's gravity, the spine slowly recompresses over a period of weeks, returning the astronaut to their original height. This physical change is just one part of the body's complex adaptation to microgravity, a suite of alterations that includes fluid shifts that cause a puffy face and bird-like legs, and bone density loss that mimics advanced osteoporosis. Studying these effects is crucial for preparing for long-duration missions to Mars and beyond, where maintaining crew health in a foreign gravitational environment will be one of the greatest challenges we face. Our own moon, for all its silent appearance, is far from a static world. It experiences its own version of earthquakes known as moonquakes, and scientists have identified several distinct types. The deepest and most powerful are triggered by the same tidal forces that are pushing the moon away from us, the gravitational tug of war with Earth stressing the lunar interior. There are also shallow moonquakes registering up to 5.5 on the Richter scale and lasting for astonishingly long periods, sometimes over 10 minutes. Because the moon is geologically more rigid and brittle than Earth, without water to dampen the vibrations, seismic waves just ring and ring like a struck bell. Then there are the thermal moonquakes, a direct result of the moon's extreme temperature swings. After 2 weeks of deep freeze darkness, the sudden sunrise heats the crust so rapidly that it expands and cracks, creating a daily chorus of tiny, predictable tremors as the lunar surface awakens. This seismic activity confirmed that the moon possesses a complex internal structure with a core, mantle, and crust, and suggests it may still be tectonically active in its own unique way. The discovery of these moonquakes hints at a dynamic world, but an even more significant revelation has been the confirmation of water ice. For decades, the moon was thought to be completely bone dry. We now know that hidden in the permanent shadows of deep polar craters, places where sunlight has not reached for billions of years, lie vast deposits of water ice. These cosmic deep freezes maintain temperatures as low as -400 degrees Fahrenheit, cold enough to trap water molecules for eons. This ice is a game changer for human exploration. It's not just about having drinking water. With the application of electricity, water can be split into hydrogen and oxygen, the core components of rocket fuel. This means the moon could potentially become a cosmic gas station, allowing spacecraft to refuel for journeys deeper into the solar system, radically reducing the cost and complexity of missions from Earth. This same resource has been found on our neighboring planet, Mars. Vast quantities of water ice are locked away at its poles and are believed to be stored in the soil over much of the planet just beneath the surface. This evidence of widespread water ice is a cornerstone in the argument that Mars was once a much warmer and wetter world, with rivers, lakes, and perhaps even a northern ocean. Finding and characterizing this ice is a primary objective for future crewed missions, as it represents a vital resource for sustaining a human presence on the red planet. The presence of this water on both our moon and our planetary neighbor fundamentally shifts our perspective from these being barren wastelands to being potential waypoints and outposts for humanity's future in space. While we're finding the building blocks of life on nearby worlds, a European Space Agency mission gave us a surprisingly intimate look at a visitor from the solar system's deep freeze. When the Rosetta spacecraft caught up with an orbited comet 67P/Churyumov-Gerasimenko, its onboard instruments performed something akin to a breathalyzer test, sniffing the comet's faint coma of gases. The results were, to put it mildly, pungent. The Rosetta probe detected a cocktail of molecules that included hydrogen sulfide, which gives rotten eggs their distinctive and revolting stench, and ammonia, which carries the sharp, unpleasant odor of horse urine. The mix also included formaldehyde, which has a pickled, suffocating smell, and hydrogen cyanide, which has a faint scent of bitter almonds. If you could stand on the surface of this comet, and you absolutely should not try, the combination of these gases would create an overwhelmingly foul odor, a stark contrast to the beautiful, pristine-looking icy traveler we see from afar. This smelly analysis, however, is scientific gold dust. Comets are considered frozen time capsules, holding pristine material from the very beginning of our solar system. The specific mix of chemicals detected by Rosetta provides a direct snapshot of the primordial ingredients that were available when the planets were forming, the same raw materials that may have been delivered to early Earth by comet impacts, potentially seeding our world with the organic compounds necessary for life to eventually emerge. From the smelly primordial ices of distant comets, we journey now to the dramatic landscapes of our neighbor Mars, home to the single largest volcano in the entire solar system. Olympus Mons is a shield volcano of such staggering proportions that it effectively redefines the word mountain. To truly appreciate its scale, picture Mount Everest, the tallest peak on our planet. Now imagine stacking 2 more Everests on top of it. That colossal height, nearly 22 miles tall, is Olympus Mons, but its true grandeur lies in its footprint. This is not a steep, jagged peak. It is a gently sloping shield built from countless flows of low-viscosity lava over billions of years. Its base would completely engulf the entire state of Arizona, sprawling over 374 miles in diameter. The caldera at its summit, the complex of collapsed craters, is about 50 miles wide, large enough to swallow a major city whole. The existence of such a behemoth is a direct consequence of Mars's unique geological history. Unlike Earth, Mars lacks plate tectonics. This means that for eons, a single, stationary volcanic hotspot was able to continuously pour lava out onto the same spot on the crust, building a mountain to heights impossible on our dynamic planet, where the movement of tectonic plates shifts the land away from the magma source, creating chains of volcanoes like the Hawaiian Islands instead of a single titan. Olympus Mons is not just a mountain, it is a frozen record of Mars's fiery, static past. While Mars hosts this monumental peak, the distant, demoted dwarf planet Pluto operates on a much slower, more leisurely clock. A single day on Pluto, the time it takes to complete one full rotation on its axis, lasts for 6.5 Earth days. This prolonged day-night cycle is a result of its small size and the weak tidal forces acting upon it, allowing it to spin at this sluggish pace. If you were standing on its frozen, variegated surface, you would witness a sunrise that creeps slowly across a landscape of nitrogen ice plains and water ice mountains, casting long, distinct shadows for days on end. The Sun itself would appear not as a disk but as an incredibly bright star, providing only about 1/900th of the light we receive on Earth, creating a perpetual twilight. This slow rotation, combined with its highly elliptical and tilted orbit, leads to extraordinarily long and complex seasons, each lasting for decades. The recent flyby by the New Horizons spacecraft revealed that despite its small size and vast distance from the Sun, Pluto is a surprisingly active world, with glaciers of nitrogen ice flowing, potential cryovolcanoes, and a complex, layered atmosphere that freezes and falls as snow as the long seasons change. Its slow day gives these geological processes ample time to shape its alien surface in ways we are only beginning to understand. This leisurely pace on a distant, frozen world presents a stark contrast to one of the most enduring and counterintuitive mysteries in all of solar science, a paradox that unfolds in our own backyard. For centuries, it has been known that the visible surface of the Sun, the photosphere, has a temperature of around 5,500 degrees Celsius. It seems logical that as you move away from this furnace, things would get cooler. But the universe loves a good paradox. The Sun's outer atmosphere, the shimmering corona that we see during a total solar eclipse, is not cooler. It is blisteringly, inexplicably hotter, reaching temperatures between 1 and 2 million degrees Celsius. This is the coronal heating problem, and it defies our basic understanding of thermodynamics. How can the atmosphere be hundreds of times hotter than the surface it surrounds? It's like walking away from a fire and suddenly stepping into an inferno. The solution to this puzzle is not found in a single source, but in a combination of energetic processes. One leading theory involves the Sun's powerful magnetic fields. The photosphere is constantly churning like a pot of boiling water, and this motion twists and tangles the magnetic field lines that arc up into the corona. These lines can become so stressed that they suddenly snap and reconfigure in a process called magnetic reconnection, releasing colossal amounts of energy in the form of heat, superheating the surrounding plasma. Another mechanism involves powerful waves called magneto-hydrodynamic waves that are generated in the turbulent surface and then travel upward, carrying their energy into the corona where it dissipates as intense heat. This superheated corona is what drives the solar wind, the constant stream of charged particles that flows outwards through the solar system, influencing space weather and creating the beautiful auroras here on Earth. So, while we have mapped the largest volcano and timed the slowest days, our very own star holds a secret at its edge that continues to challenge the brightest minds in physics. Beyond our familiar solar system, adrift in the cold, dark vastness between stars, there exists a class of worlds that knows no sunrise. These are rogue planets, entire worlds that have been violently ejected from their home solar systems and now wander the interstellar void alone. Picture an Earth-sized object, or one even larger, flung away by the gravitational slingshot of a passing star or a chaotic dance with a giant planet in its youth. Once torn from their stellar anchor, these planets are set on a perpetual journey through the galaxy, with no star to warm their surfaces or provide a cycle of day and night. Their existence is one of permanent, deep freeze darkness. While this might sound like the ultimate cosmic loneliness, these rogue worlds are far from rare. Astronomers estimate there could be billions, perhaps even trillions, of them roaming the Milky Way, outnumbering the stars themselves. Some of these dark nomads might even have thick atmospheres that trap internal heat from their formation, creating subsurface oceans under icy crusts where life, in theory, could find a way to persist, completely independent of the light of any sun. They are the ultimate survivors, silent testaments to the turbulent and chaotic nature of planetary system formation. And that same galaxy, which is home to these wandering worlds, is itself engaged in a slow-motion dance of cosmic proportions. We've mentioned the inevitable collision with the Andromeda Galaxy, but let's truly envision what that future event will mean for the night sky. In about 4.5 billion years, as the two galaxies begin their first close pass, the view from Earth would be utterly transformative. Instead of the faint, wispy smudge of Andromeda we see today, it would swell to dominate the heavens, a colossal, tilted wheel of stars and dust stretching across the entire celestial sphere. As the gravitational interaction intensifies, long, graceful streams of stars would be pulled from both galaxies, creating brilliant, shimmering bridges and tails arcing overhead. The pace of change would be glacial from a human perspective, but over millions of years, the familiar structure of the Milky Way would be completely torn asunder and rewritten. The core of the Milky Way and the core of Andromeda, each likely harboring a supermassive black hole, would begin a gravitational waltz of their own, eventually merging into a single, even larger black hole. The most profound aspect of this entire cosmic merger is that space is so empty that the vast majority of stars will simply pass by one another, their solar systems remaining intact. The night sky, however, would become a constantly evolving, dazzling spectacle of unprecedented stellar density, with new star-forming regions igniting like fireworks as clouds of gas and dust collide, lighting up the new combined galaxy, which we call Milkomda, for eons to come. To fully appreciate the scale of this galactic collision, you first have to grasp the sheer size of our own Milky Way. We often see it illustrated as a relatively compact spiral, but its dimensions are almost beyond human comprehension. Consider this: a beam of light traveling at the universe's ultimate speed limit of 186,000 miles per second would require 100,000 years to journey from one edge of our galaxy to the other. That's 100,000 years of travel at a speed that could circle the Earth 7 times in a single second. This means that the light from a star at the far end of the galaxy that we see tonight began its journey to Earth around the time our earliest human ancestors were first beginning to spread across the globe. Our own solar system is located in a relatively quiet suburban spiral arm, about 27,000 light-years from the galactic core. From our vantage point, the combined glow of the countless stars in the disk appears as the pale, milky band that gives our home its name. This staggering scale puts everything into perspective. Our entire solar system, with its planets, asteroids, and comets, is but a single, minuscule speck within a structure of such grandeur that it takes light, the fastest thing there is, 1,000 centuries just to cross it. While we often picture space as an infinite, distant realm, the official starting line is much closer than you might think. The universally accepted boundary between our atmosphere and outer space is known as the Kármán line, and it sits just 100 kilometers or about 62 miles above sea level. To put that in perspective, if you could drive a car straight up at highway speed, you could reach the edge of space in little over an hour. This invisible threshold isn't arbitrary. It marks the altitude where the atmosphere becomes so incredibly thin that a conventional aircraft can no longer rely on aerodynamic lift to fly and must instead achieve orbital velocity to stay aloft. This means that space is, in a very real sense, our planet's immediate neighbor. It's a profound realization that the vast, star-filled expanse doesn't begin light years away, but is practically just over our heads, a short hop for a rocket but an impossible climb for any plane. Reaching that boundary was one of humanity's greatest achievements, but the first conscious Earthling to cross it and enter orbit was not a human. Her name was Laika, a stray dog plucked from the streets of Moscow. In 1957, just a month after the Soviet Union stunned the world with the first artificial satellite, Sputnik 1, they launched Sputnik 2 with the gentle, mixed-breed dog sealed inside a tiny, pressurized cabin. The mission was a desperate, politically driven rush, and tragically, the technology for a safe return had not yet been developed. Scientists knew from the beginning that Laika was on a one-way journey. For several hours, her vital signs were transmitted back to Earth, proving that a living creature could survive the violence of launch and the weightlessness of orbit. But within a few hours, due to a failure of the temperature control system, the capsule overheated dramatically. Laika's sacrifice provided the first crucial data on how life responds to the space environment, paving the way for human spaceflight just a few years later. Her story is a poignant and somber chapter in our cosmic ascent, a reminder that our first steps into the high frontier were paid for with the loyalty and life of a helpless animal. Once humans finally followed Laika across that threshold, they encountered a universe of strange new physical phenomena, including a profound change in one of our most basic human expressions, crying. In the weightless environment of orbit, tears don't fall. Without gravity to pull them down, the saline liquid simply pools on the surface of the eye, forming a growing, quivering bubble that clings to the eyelid. If more tears are produced, this bubble can grow large enough to detach and float away as a perfect, shimmering sphere of salt water drifting through the cabin. While this might sound whimsical or even beautiful, astronauts report that the sensation is actually quite uncomfortable. That ball of fluid can cause a stinging sensation in the eye, and the lack of the familiar cleansing flow down the cheek means the emotional and physical release we associate with crying is fundamentally altered. It's a small, intimate example of how the most fundamental aspects of our human experience, from the grief of a sob to the joy of a tearful reunion, are physically transformed when we leave the world that shaped our biology. These three facts together, the surprising proximity of space, the poignant story of its first explorer, and the altered reality of human emotion in orbit, paint a deeply human picture of our venture into the cosmos, blending Cold War history, biological adaptation, and the enduring spirit of exploration. Moving from the slow geological cooling of Mercury, we find that our closest planetary neighbor, Venus, is hiding a surprisingly fiery secret beneath its thick, cloudy shroud. For decades, scientists debated whether Venus, a world similar in size and structure to Earth, was still volcanically active or if it had long ago locked its internal fires away. That question was answered definitively in 1991, when NASA Magellan spacecraft used radar to pierce the planet's opaque atmosphere and map its surface. What it revealed was a landscape dominated by volcanoes and vast lava plains, but the evidence for current activity remained circumstantial until very recently. A breakthrough study published in 2023 re-examined Magellan data from a specific region and found that a volcanic vent about 1.6 kilometers wide had significantly changed shape over an 8-month period, strongly suggesting that it had erupted during that window of time. This was the smoking gun, the first direct evidence of active volcanism on Venus. This discovery transforms our understanding of the planet from a stagnant, fossilized world into a dynamic one, where internal heat still finds a way to breach the surface, likely through massive outpourings of thick, slow-moving lava. The implications are profound, as it suggests that Venus, despite its crushing surface pressure and scorching temperatures, shares a fundamental geological driver with Earth, a reminder that planetary heat engines can remain active for billions of years, even under the most hostile conditions. While Venus offers a glimpse of familiar, if extreme, geology, the universe is capable of conjuring weather patterns that are truly alien. 34 light-years away, orbiting a star in the constellation Vulpecula, is the exoplanet HD 189733b. This world is a hot Jupiter, a gas giant that orbits so close to its star that it is tidally locked, with one side in permanent, scorching daylight and the other in endless night. This proximity creates unimaginable conditions. Daytime temperatures soar to a searing 1,700 degrees Celsius, hot enough to vaporize metal. But the planet's most bizarre feature is its weather. The intense heat on the dayside rips apart molecules, creating an atmosphere filled with vaporized silicates, the same material that makes up glass and sand. Then, powerful supersonic winds, estimated to blow at over 5,000 miles per hour, carry this silicate-laden gas to the colder night side. As the gas chills, the silicate particles condense directly out of the atmosphere, forming tiny droplets of liquid glass. These droplets then fall as rain, a horizontal, blistering downpour of molten glass propelled by hurricane-force winds. Scientists believe that as this glass rain reaches the boundary of the planet's permanent twilight zone, it may re-evaporate and begin the cycle all over again. It is a world of violent, cyclical storms where the precipitation is not water, but a substance we build windows from, a stunning example of the exotic and often terrifying diversity of planets that exist beyond our solar system. If you think raining glass is extreme, our own cosmic backyard holds the undisputed champion of volcanic fury. Jupiter's moon Io, slightly larger than our own moon, is the most volcanically active world in the entire solar system. Its surface is a psychedelic tapestry of yellow, orange, and red, colored by sulfur and sulfur dioxide frost, and it is littered with hundreds of active volcanoes and enormous lava lakes. The driving force behind this incredible activity is not radioactivity in its core, as is the primary heat source for Earth and Venus, but the immense gravitational tug-of-war between its parent planet Jupiter and its sister moons Europa and Ganymede. This gravitational interaction creates what is known as tidal heating. As Io orbits Jupiter, the competing gravitational pulls from the other moons cause its orbit to be slightly elliptical. This means its distance from Jupiter is constantly changing, and the planet's colossal gravity relentlessly squeezes and stretches the moon's interior, generating immense friction and heat through this continuous flexing. The process is so effective that it melts a significant portion of Io's rocky mantle, creating a global subsurface ocean of magma that powers its volcanoes. These volcanoes are not just frequent, they are colossal, with plumes of gas and dust that can shoot hundreds of kilometers above the surface, and lava flows so hot they reshape the landscape on a daily basis. Io is a world in a constant state of geological upheaval, a testament to the fact that you don't need to be close to a star to be a world of fire. Sometimes the gravitational dance with your neighbors is more than enough to set your very core ablaze. We are about to enter the realm of the universe's deepest and most humbling truths. For all the stars, galaxies, and planets we have discussed, for all the cosmic phenomena we can observe and measure, we are fundamentally blind to the vast majority of what actually exists. Everything you have ever seen in a telescope, every star in every galaxy, all the planets, comets, and dust clouds, all of it combined constitutes a mere 5% of the total content of the universe. The other 95% is completely invisible to us, a cosmic phantom that we can only detect through its gravitational influence. This hidden cosmos is split into two mysterious components, dark matter and dark energy. Dark matter is an invisible substance that does not emit, absorb, or reflect any light, making it completely undetectable by our telescopes. We know it's there because of its immense gravitational pull. The way galaxies spin, for instance, defies the laws of physics as we understand them. The visible matter alone does not provide enough gravity to hold them together. They should fly apart, but they don't because they are embedded within enormous, invisible halos of dark matter, whose gravity provides the necessary glue to bind entire galaxies together. Then there is dark energy, an even more perplexing force that makes up about 70% of the universe. Unlike gravity, which pulls things together, dark energy is a repulsive force that is causing the expansion of the universe to accelerate. It is the dominant component of the cosmos, and we have virtually no idea what it actually is. So when you look up at the night sky, you are not seeing the true cosmos. You are seeing the decorative lights on a structure whose walls, foundation, and the very space between them are made of something we cannot see or comprehend. Juxtaposed against this profound and invisible mystery is a delightful piece of cosmic chemistry that feels almost whimsical. Near the center of our Milky Way galaxy, in a massive dust cloud known as Sagittarius B2, astronomers have discovered a surprising molecule, ethyl formate. This is the very same ester that gives raspberries their distinctive, sweet scent and is a key flavor component in rum. Yes, the center of our galaxy, a region dominated by a supermassive black hole and swirling with immense energies, has a distinct aroma of raspberries and a hint of rum. Now, before you picture a cosmic candy store, it's important to understand that you wouldn't actually be able to take a sniff. The cloud is a vacuum and the molecules are spread incredibly thin. But the detection of ethyl formate, along with other complex organic molecules, is a revelation. It tells us that the chemical building blocks for the flavors and scents we associate with life on Earth are being manufactured in abundance in the giant molecular clouds where stars and planets are born. The universe isn't just brewing the elements for life. It's also concocting the familiar fragrances of a fruit basket, scattering these aromatic molecules across the galaxy, as if to remind us that even in the most extreme environments, the chemistry of our own world is deeply connected to the chemistry of the cosmos. If the galactic center smells like a familiar kitchen, then our final stop in this trio is a place of profound emptiness that defies all familiar notions of space. In the constellation of Boötes, there exists a region of space so vast and so empty that it has been named the Boötes Void, or the Great Nothing. This is not just a patch of space with few galaxies. It is a spherical region about 250 million light-years across that is remarkably, unnervingly barren. In a volume of space that should contain thousands of galaxies, astronomers have found only about 60. To grasp the scale of this emptiness, consider that if our own Milky Way galaxy were at the center of the Boötes Void, we would not have known other galaxies existed until the 1960s because the nearest ones would be too far away for our telescopes of the time to see. The existence of such a void challenges our understanding of the large-scale structure of the universe. The cosmos is often described as a cosmic web, with long filaments of galaxies surrounding vast, empty bubbles. The Boötes Void is one of the largest of these bubbles ever discovered. How it formed is a matter of intense debate. It could be the result of multiple smaller voids merging over billions of years, or perhaps the imprint of some colossal, ancient event that cleared out the matter in this region. It stands as a stark reminder that the universe is not only full of invisible forces and surprising scents, but also contains staggering deserts of nothingness, immense regions where the conventional bustle of the cosmos simply gives way to an almost impossible silence. Shifting our gaze from the fiery chaos of Io to the outer solar system, we find a world that feels strangely familiar yet utterly alien. Saturn's largest moon, Titan, is the only place beyond Earth where we have found stable bodies of liquid on its surface. But you wouldn't want to go for a swim. Instead of water, Titan's rivers, lakes, and seas are filled with a frigid mixture of liquid methane and ethane, hydrocarbons that are gases here on Earth but which flow as liquids in Titan's deep freeze temperatures of -190 degrees Celsius. Thanks to the Cassini-Huygens mission, we have radar maps showing vast expanses of these dark, smooth lakes near the Moon's polar regions, with one Kraken Mare being larger than North America's Great Lakes. The hydrologic cycle on Titan is a bizarre, slow-motion mirror of our own. The weak sunlight evaporates methane from these lakes. It forms clouds in the thick, nitrogen-rich atmosphere, and then it rains down, carving river channels and filling the basins below. This makes Titan an extraordinary laboratory for studying chemistry that might mimic the prebiotic conditions of early Earth, but at a temperature so cold that water is frozen solid as hard as rock. While Titan presents a distorted reflection of Earth's landscapes, our neighbor Mars offers a dramatic inversion of one of our most cherished daily spectacles, the sunset. Here on Earth, our sunsets are painted in brilliant shades of red and orange because the molecules in our atmosphere scatter the shorter, bluer wavelengths of light, letting the longer red and orange wavelengths pass through to our eyes, especially when the sun is low on the horizon. On Mars, the opposite happens. The thin Martian air is perpetually filled with incredibly fine dust particles rich in iron oxide, the same compound that gives the planet its rusty color. These tiny dust particles are perfectly sized to scatter the longer, redder wavelengths of light away from the line of sight, while allowing the shorter blue light to penetrate the atmosphere more directly. The result is that in the moments before the sun dips below the Martian horizon, the sky around it takes on a cool, hazy blue or bluish-gray hue, a serene and otherworldly sight captured beautifully by rovers like Spirit, Opportunity, and Curiosity. It's a daily reminder that even the most fundamental and beautiful experiences are dictated by the specific physical properties of a world. And that brings us to one of the most enduring symbols of human exploration, left behind on our own moon. Many who gaze at photos from the Apollo missions notice that the American flags appear to be waving, as if in a breeze. This has fueled conspiracy theories for decades, but the simple truth is far more interesting. The flags are not waving, they are frozen in place. The astronauts had trouble inserting the horizontal crossbar fully into the top of the flagpole, leaving the flag loosely furled. When they planted it and twisted it back and forth to get it into the lunar soil, that inertia caused the fabric to swing back and forth for a moment. With no air resistance to slow it down, that motion continued for much longer than it would on Earth, creating the appearance of a flag fluttering in a non-existent wind. As for their current condition, more than 50 years of exposure to the lunar environment has almost certainly taken a drastic toll. The unfiltered, intense ultraviolet radiation from the sun bombarding the lunar surface is powerful enough to break down chemical bonds in dyes and fabrics. Without an atmosphere to provide any protection, it is highly likely that the iconic stars and stripes have been completely bleached, leaving behind nothing but stark, blank white flags standing as silent, ghostly monuments to humanity's first steps on another world. Our journey through the solar system takes a surprising turn back to the swift-footed world of Mercury, where a year is a fleeting 88 Earth days. To live there would be to experience a birthday every 3 months, a dizzying calendar driven by its position as the innermost planet. Being so close to the Sun's immense gravitational pull, Mercury must race around its orbit at a breakneck speed of nearly 170,000 kilometers per hour to avoid falling in, completing its solar circuit in less than a quarter of our own year. This blistering orbital pace creates a bizarre disconnect with its slow rotational spin, meaning a single day on Mercury from one sunrise to the next actually lasts for 176 Earth days. This makes for a world where you could celebrate 2 birthdays before the Sun even finished rising once. From the swift passage of time on one world, we move to a persistent myth about a view from space. You have likely heard the claim that the Great Wall of China is the only human-made structure visible from orbit with the naked eye. It's a captivating idea, but unfortunately it is not true. From low Earth orbit, where the International Space Station travels, astronauts can spot many large-scale human creations. The pyramids at Giza under perfect conditions, major city lights at night, and even the massive green circles of center pivot irrigation in arid regions are all discernible. The Great Wall, however, is simply not wide enough and is built from materials that blend in with the natural soil and rock of the surrounding landscape. Its color and texture make it incredibly difficult to distinguish from the mountains it traverses. The myth likely stems from a misunderstanding about its scale. While it is immensely long, its width is only about 6 meters on average, far below the resolution of the human eye from 250 miles up. So, while it stands as a monumental feat of human engineering, its visibility was a cosmic exaggeration. This clarification of a terrestrial view leads to one of the most mind-bending realities of the cosmos on its very largest scale. The space between galaxies is not static, it is actively expanding, and for the most distant galaxies we can observe, this expansion is carrying them away from us at velocities that exceed the speed of light. Now, this seems to violate a fundamental rule of Einstein's relativity, which states that nothing can travel through space faster than light. The critical distinction here is that these galaxies are not moving through space in the conventional sense. Instead, the very fabric of spacetime itself is stretching, and it is this stretching that increases the distance between widely separated points. Think of the universe as a loaf of raisin bread rising in the oven. Each raisin is a galaxy. As the dough expands, the raisins all move away from each other. 2 raisins that are very far apart will be separated by more dough and will therefore recede from each other faster than 2 raisins that are close together. The raisins themselves aren't traveling through the dough, they are being carried along by the expansion of the dough. In our universe, the dough is space-time, and for galaxies separated by enough distance, the cumulative stretching between them adds up to a recession velocity greater than light speed. This is not a violation of relativity because no information or matter is actually traveling through space at that speed. It is the space between them that is growing. This is why we can never see or reach these ultra-distant galaxies, even in principle. The space between us is expanding so quickly that their light can no longer cross the ever-widening gulf. They have passed beyond our cosmic event horizon, forever disappearing into the expanding dark. As we approach the end of our cosmic journey, we arrive at 3 final facts that perfectly capture the incredible range of our exploration, from the intimate changes within our own bodies to the grand census of our galactic home, and out to the most violently magnetic objects ever discovered. First, let's consider the astronaut, a human being adapting to life away from Earth. In the microgravity environment of space, the human heart undergoes a subtle but significant physical transformation. It becomes more spherical. Here on Earth, our hearts are accustomed to fighting gravity every second of every day, pumping blood upward against a constant downward pull. This constant effort gives the heart a distinctive, slightly elongated, pear-like shape with powerful muscular walls. In the weightlessness of space, that daily battle suddenly ends. Without gravity to oppose, the heart doesn't have to work as hard, and the blood, no longer pulled downward, redistributes more evenly throughout the body, often pooling in the chest and head. This shift in fluid dynamics and workload causes the heart to relax and become more round, a change that has been observed in astronauts after just a few weeks in orbit. While the heart is a remarkably adaptable muscle and generally returns to its normal shape upon return to Earth, studying this effect is crucial for understanding the long-term health of astronauts on extended missions, revealing how profoundly our biology is tied to the planetary environment that shaped us. This personal transformation inside an astronaut stands in stark contrast to a grand comparison that recontextualizes our entire planet. We often think of the Milky Way as a place of unimaginable vastness, filled with hundreds of billions of stars. Yet, here on our single, humble world, the number of trees is so immense that it rivals the stellar population of our entire galaxy. Scientists estimate that there are roughly 3 trillion trees on Earth. Now compare that to the estimated number of stars in the Milky Way, which astronomers calculate to be between 100 billion and 400 billion. That means there are significantly more trees on our planet, likely between 7 and 30 times more than there are stars in our home galaxy. This isn't to diminish the scale of the cosmos, but to elevate our appreciation for the overwhelming, teeming abundance of life on our own world. Every forest, from the sprawling Amazon to the boreal taiga, every lone tree in a park, and every sapling pushing through the soil, is part of a population that numerically dwarfs the suns in our galactic neighborhood. It's a humbling and powerful reminder of the unique, vibrant, and precious nature of our living planet in a cosmos that is, for the most part, stark and barren. And if the quiet growth of a tree represents one end of the cosmic spectrum, then the magneta represents the other, a phenomenon of almost pure destructive energy. We've already discussed neutron stars, the incredibly dense remnants of supernova, but a magneta is a neutron star turned up to 11. It is a neutron star with a magnetic field so powerful that it defies all analogy. The magnetic field of a typical magneta is 1,000 trillion times stronger than Earth's magnetic field. To put that inconceivable power into a tangible scenario, if a magneta were located as far away as the Moon, about 240,000 miles, its magnetic field would still be strong enough to magnetically strip the data from every credit card on Earth. It wouldn't just corrupt the magnetic strip, it would rearrange the magnetic domains of every piece of metal on the planet. The forces involved are so intense that they can actually crack the star's own immensely strong crust, producing starquakes that release colossal bursts of gamma rays and X-rays. In 2004, a magneta 50,000 light-years away released a flare so powerful that it actually compressed Earth's magnetosphere and partially ionized our upper atmosphere, despite being halfway across the galaxy. These objects are the universe's ultimate magnets, born from the collapse of stars with especially powerful magnetic fields, and they serve as a violent reminder that the cosmos is capable of generating forces so extreme they can warp the very structure of matter itself from across interstellar distances. And now we reach the 50th and final fact, a concept that ties together everything we have discussed and brings our cosmic journey full circle, back to the very beginning of everything. The oldest light in the universe is not trapped in a distant galaxy or locked away in some far-off nebula. It is here, right now, all around us, a silent, cold glow that fills every cubic centimeter of the space you occupy. This is the cosmic microwave background radiation, and it is the universe's baby picture, the cooled and faded remnant of the Big Bang's first and most brilliant flash of light. To understand its significance, we need to rewind the cosmic clock. For the first 380,000 years after the Big Bang, the universe was an opaque, searingly hot soup of plasma, so dense that light particles, photons, could not travel any meaningful distance without immediately colliding with and being absorbed by a free electron. The universe was a brilliant, featureless fog. Then, as expansion continued, the universe cooled just enough for a monumental transition to occur. Electrons combined with protons to form the first stable hydrogen atoms in an event known as recombination. Suddenly, the road was clear. The photons, which had been trapped for eons, were finally set free, streaming out across the universe in every direction. That first flash of liberated light is what we detect today as the cosmic microwave background. Of course, it is no longer the brilliant, visible light it once was. The relentless expansion of the universe over the ensuing 13.8 billion years has stretched the very fabric of space-time, and in doing so, it has also stretched the wavelength of that primordial light. What was once a blistering, short wavelength visible glow has been stretched and cooled into the long wavelength microwave part of the spectrum, corresponding to a temperature of just 2.7 degrees above absolute zero. This is why we can't see it or feel it. It is a frigid, faint whisper of radiation that permeates the entirety of existence. The discovery of this background hum in 1965 by Arno Penzias and Robert Wilson was arguably the single greatest piece of evidence for the Big Bang theory. They were using a large radio antenna and found a persistent, uniform static that came from every direction in the sky, a noise they could not eliminate no matter what they did. This noise was the echo of creation itself, and it earned them a Nobel Prize. But the story doesn't end there. Modern satellites like the Cosmic Background Explorer, the Wilkinson Microwave Anisotropy Probe, and the Planck spacecraft have mapped this radiation with exquisite precision, and they found that it is not perfectly smooth. There are tiny fluctuations in its temperature, variations on the order of 1 part in 100,000. These minute ripples are the imprint of the seeds of all cosmic structure. They represent the slight over-densities and under-densities in the early universe, the gravitational wells that, over billions of years, would pull in matter to form the very first stars, galaxies, and the colossal cosmic web we see today. Every galaxy cluster, every swirling spiral arm, and every solitary star, including our own sun, owes its existence to those faint patterns in the cosmic microwave background. So, the next time you see static on an old analog television, know that a tiny fraction of that snow, about 1%, is actually the cosmic microwave background radiation, the oldest signal it is possible to receive. It is the fossilized light from a time before there were stars, before there were planets, before there was anything but the hot, dense, expanding embryo of the cosmos. It is the universe's first light, and it is still shining, a permanent, all-encompassing monument to our ultimate origin, connecting every single point in space, including the room you are in right now, directly back to the moment of its birth. And so we arrive at the end of our voyage, a journey that has taken us from the silent, enduring footprints on our moon to the searing, glass-raining skies of distant exoplanets, from the unimaginable density of a neutron star to the staggering emptiness of the Boötes void. We have uncovered a universe that is not the serene, static backdrop we perceive on a clear night, but a dynamic, chaotic, and breathtakingly violent arena, a place of constant transformation and extremes that defy our everyday intuition. These 50 facts are more than just a collection of trivia. They are a set of keys, each one unlocking a new perspective on our place in this grand cosmic story. They remind us that we are living on a fragile, vibrant world teeming with more trees than there are stars in our galaxy. Yet we are orbiting a star that itself is but a tiny speck in a sea of 1 septillion suns. We are surrounded by mysteries, from the dark matter and dark energy that constitute 95% of reality to the faint, cold echo of the Big Bang that still permeates every inch of space around us. This journey reveals a cosmos that is at once humbling in its scale and intimately connected to our own existence, a universe that brews the building blocks of life in giant molecular clouds and scatters the scent of raspberries across the galactic center. It is a story still being written, with planets shrinking, rings dissolving, and galaxies set on a collision course that will reshape the heavens billions of years from now. We hope this exploration has ignited your curiosity and expanded your sense of wonder, showing you that the universe is far stranger, more beautiful, and more mysterious than we could ever imagine. Now, we would love to hear from you. Of all the mind-bending facts we shared today, which one surprised you the most? Was it the future collision with Andromeda, the silent symphony of a supernova, or the thought of a diamond world larger than our own? Let us know your favorite in the comments below. We read every single one. If you enjoyed this journey to the edge of understanding and want to continue exploring the final frontier with us, please consider subscribing to the channel and hitting the notification bell so you never miss an adventure. There is always more to discover, and we can't wait to continue unraveling the secrets of the cosmos with you. Thank you